We touched on the cross-platform rendering in the last video, and now we'll just talk a bit more, not necessarily just about Skia, but how the cross-platform works in Avalonia in general. How do we code for multiple platforms? So the first thing it mentions, and this is really important, this is the reason I used Avalonia from the very beginning, is something as simple as drawing a button on screen. Because we don't wrap native platform controls, this is the absolute key. There is no such thing as a Windows Win32 button being reskinned, which is what every other cross-platform UI tool has ever done. Avalonia completely remakes the UI and renders it again using Skia. This means that if you draw a button on one platform, it will always be exactly the same across every platform, full stop, which is absolutely game-changing. It's just a little statement here, but this is a massive point of the cross-platform architecture. On top of that, we then build views, view models, business logic, styling. All of this is completely cross-platform with every single platform it supports. There's a few things like, say, there's hardware sensors on phones like GPS that don't exist on Windows, for example. There's ways around that using your normal defined directives or detecting what platform you're on and using interfaces. So nothing special here. This is how you would typically integrate anything that needs to work across multiple different domains. You'd simply use interfaces. So it's just mentioned that these are common things that might want to be worked around. And if you did want these, like push notifications on phones, there's even a library here, the Microsoft MAUI Essentials, that provides common layers for that as well. And then a little bit of documentation here of the structure of a solution. So this is going to be easier to take a look at. There's a core which has view models, views, business logic. There's a desktop entry point for desktops. And then there's Android and iOS, which is a separate thing. And then there's browser, which is another thing. So really, these two are very similar. Desktops are similar, and browser is on its own. So if we just went into here, made a new solution, let's make a cross-platform app. So if we make this cross-platform app, this is where you'll now see the exact thing we're talking about. So in here, you now have this unnamed application, as in there's no extension at the end of it. And if we extend, here are the views, view models, and images and assets. And you'll see here, views, view model, business logic, anything that can be completely cross-platform. So your entire application wants to live in here. Like 99.9% of your application ends up living in here. These are only relevant if you want to do very specific things. There's very few cases where I would touch these ever. Once you're making an Avalonia app, your application lives in here. But for Android, let's take a quick peek, and you can see in the application, ignore the build errors. We don't have the tooling installed yet for this, but we're just looking at the fact that this is inheriting an application. It's got its own actual Android application startup here, which then gets into the app builder and ultimately calls then the customized app builder. So this is then the entry point that leads to a shared application. If we look at the iOS into main, you'll see again, this is then different altogether, and it uses a UI application, which is an Apple thing, and it goes to app delegate, which in here is an Avalonia app delegate, which then calls customized build, which calls the same thing that Android did. So just another route to the same step. The desktop we should be familiar with, we've already looked at. This calls the build Avalonia app, which calls appbuilder.configure. So you can see all of these are ending up configuring ultimately an app. So that's what all of these are intending to do. They're just ultimately calling into the same app. Now, if we took a look at the fully shared library and go into this application, we can see here the app will get called on framework initialized from every single platform. So whichever one of these you now launch it from, you're going to end up in framework initialized. And then in here is where we do the check if we're on a desktop. And this is what I've been talking about in a few videos prior. We detect if we're on a desktop, and if so, we set the desktop's main window because that's specific to desktop applications. And now we set the data context to a main view model. However, if we are on a single view factory application, this is iPhone and Android, we then set its main view factory, which is the thing that the mobiles use, and we set its main view to something different. So the problem with this template at the beginning is you have a main window and a main view. You've got two different things now going on. So the first thing I ever do with these templates is I take these views and view models, and here you can see it's actually now done in the latest templates. All this main window is a complete wrapper that then injects the main view. So when we are having a difference here, we're injecting a main view or a main window. This is exactly the same as doing a main view, with the exception of it's just wrapped in a window. So ultimately now, instead of the main window being the place where everything lives, because this is a desktop specific thing, The desktop window just wraps the view, and now the main view, which gets injected into mobiles, is just a user control. So this is now our universal entry point to the application that works across all platforms. And then on a single view application, we have the main view. So actually, one of these is the browser, one of them is the mobile. I might have those two back to front, but you can just debug this to find out which is which. You can put a breakpoint on and step through which ends up being which. And if we look into the browser, you can see it does a browser single view lifetime. So that would most likely mean, without debugging, this is the browser, this is the mobiles as expected. So all that ends up being is that you can pretty much leave the template as is, focus inside this folder, and trust that main view is where your application starts in terms of the visuals. And the template's already set up as such that it's doing that for you, but that's how it's put together. And then if we want to look at handling platforms differently, as in detecting what platform we're running on, because we might want to show something different. In bindings, for example, you can use this OnPlatform that allows us to then specify the default value or which platform we're on and return a different value. We can do it in code behind by checking the OperatingSystem.is Windows, is Android, is iOS, and doing some code behind logic different. In compilation, we can do the defines. So we have, for example, Android and iOS as defines if you don't want code physically even getting compiled into source. And this is when you're doing things that are truly specific to a single platform, like Android having an orientation fetch by its API call. This can't live in a Windows or Mac environment. It won't even compile. So you can just use define directives there, preprocessor directives. And in order to then support that in the core project, because you want the logic of whatever that does living in this universal app, you make an interface in here and you make the implementation in the actual platform-specific project. So not specific to Avalonia as such there, that's just how you abstract away multiple platforms. And then it recommends using dependency injection, which we'll come to. And if you're struggling of which mechanism of these to use, this is a little handy table that recommends when to use which. So when to use the on-platform versus runtime detection versus compilation, and so on.